Systems and components 13. This might be a basic question, but how can we differentiate using the COP of a refrigerator versus COP of a heat pump equation? How do we know if this is a refrigerator, if this is refrigeration or a heat pump? Yeah, so it is a basic question, but if your exam was tomorrow and you asked this question, it would make me a little nervous. But if you haven't worked with chillers or you haven't encountered a question about chillers, this is the time where you figure that out. You're in the systems and components module. And for the first time, you're getting a question to find the COP for a chiller. And a chiller is a machine that makes chilled water. So it is certainly a refrigeration cycle that's running in the chiller, and that is the magic word. That's the key word in the problem. The other hint, and this is not as ironclad as the word chiller is that it refers to a refrigerant, 134A. But even in a heat pump, which has a reversing valve and can run the cycle in both directions for removing heat from a chilled space or adding heat to a warmed space, there are gases that are used in heat pumps, which might still in some circumstances be referred to as refrigerants, even though those heat pumps can operate in both directions. So you could get caught off guard by that. I was not intending to be tricky in this problem. The refrigerant is being used for a refrigeration cycle. So this one was pretty straightforward. And that's the story for a chiller. A chiller is always making chilled water. That's a water glycol mix, but always cooling some liquid medium for distribution via pumping, and then that goes to air handlers and other process cooling devices. The opposite, well, if you're in a building that does its cooling with chilled water, it probably does its heating with a boiler, which is not the opposite. But there are products for residential applications, and maybe they make them for commercial applications too, although I haven't seen it. You can get a hot water heater for your house, which is a heat pump hot water heater. So it's running a refrigeration cycle in reverse, a heat pump cycle, and it's moving heat into the water. And what's cool about that is it's efficient. It has a COP. It's using electricity to do it, but it's not like it's just one for one. Every watt you put into this thing goes into the water. You're actually getting some coefficient of performance, so there's a multiplying effect. And if it's easier to get electricity than it is to get natural gas for whatever reason where you are to have a traditional gas-fired hot water heater, or you certainly wouldn't want to necessarily have just a pure electric hot water heater if you could avoid it, because that's just going to be one for one, and you're going to spend 4 times as much or more to heat your water than if you had a heat pump hot water heater. But they're more expensive up front. They're more complex because it's running the cycle, so there's more things that can break and probably less technicians that know how to troubleshoot them. So, it's not a recommendation to get one, but I just wanted to sort of acknowledge your question that just because there's a refrigerant being used, you could technically see that being used in a heat pump application. So it is a fair question, but now that you've asked it, you'll never forget that a chiller is for cooling and nothing more.